Hi guys, so today we're going to go over the domain and range of each function. So mind you, domain is all the x values that the function can have. So rather than find out all the x values that x could be in this function, we're just going to filter it down by finding all the values that x cannot be, which are known as your vertical asymptotes, but we'll get to that at a later time. So a rational function essentially is just a fraction. What you can never have in a fraction is a zero denominator. So that's where I'm going to start off. I'm going to set my denominator equal to 0. So this will be 3x squared minus 8x plus 5 equals to 0. Now, if you have not watched the factoring video, I know it's an Algebra 2 review, but I do use a different method that may or may not work for you, but it's worth a try looking. Could help. So I multiply first times last. So 3 times 5 gives me 15. I need two numbers that will multiply to be a times c, which is 15, because remember, quadratic is ax squared plus bx plus c. Okay, so I need two numbers that multiply to be 15 and add up to be b, which is negative 8. So rather than find the numbers off the bat, just list all the numbers that multiply to be 15. We can start off with 1 and 15, 3 and 5. None of these actually add up to be negative 8. So remember, they could also be two positive numbers that multiply to be 15 or two negative numbers that multiply to be positive 15. And with that, we find the two numbers that also add up to be negative 8. So with these two numbers, using the factoring method that I use in the other video, I always put ax over each number. A would be 3, split up the x squared. The reason I do this is because I can reduce from here if possible, giving me the first fraction as x over negative 1. The second fraction, nothing happens, I'll just bring it down. And each fraction represents each parentheses. So the first one, x over negative 1, means x minus 1. The second fraction, 3x minus 5, will be parentheses 3x minus 5. Remember that the other side equals to 0. I'm bringing that down. Since it's factored and the other side is 0, I can do zero product property, meaning set each parentheses equal to 0. So x will equal 1. And here, add 5 to both sides. 3x equals 5. X is being multiplied to 3, so we divide both sides by 3. So x equals 5 over 3. Now remember what these two values represent. These two values represent the two x values that would make my denominator 0. So these are the two values that x cannot be. So for your domain, I believe they write it in set notation. First, they note that it could be an element of all real numbers, but then they also note from there, and mind you, this is just standard. Then they note from there in your multiple choice options what it cannot equal to, which is going to be 1 and 5 over 3. So this should be all one line, by the way. I just ran out of room. Notice that the second problem we're finding the domain for, it should look a little familiar. So I'm just going to write this out. I want you to keep in mind that technically the first rule of any factoring problem is to factor out a GCF. So if I'm going to set my denominator equal to 0, again, I'm going to find everything that x can't be in order to find my domain, which are all the values that x can be. But I want you to note, if I set my denominator equal to 0 and I factor, the first step of any factoring problem is to see if there's a GCF and factor it out. There is. All three terms are separated by plus and minus signs, have x in common. So if I factor it out, I'm left with 3x squared minus 8x plus 5 equals 0. So as you look in the parentheses, we've actually already factored that. So I'm going to bring down the x, And since I already know what this parentheses is because I factored it in the previous problem, it'll be x minus 1 and 3x minus 5. It's factored in the other side equals to 0. Now, one thing to note is that zero product property means that I set each factor equal to 0. So in this case, I would also set my GCF equal to 0. We already know this one is going to be x equals to 1 and x equals 5 over 3. So in this case, the domain, again, x such that x is an element of all real numbers, and then x cannot equal, I don't know why I just keep running out of room, but this should be one line. X cannot equal 0, 1, or 5 over 3. All right, so then moving on from here, we also have a cell phone company that charges $500 for a new cell phone and $80 for a monthly plan. So we're going to have our rational function, which represents the average cost of paying off the repairs. And from there, we want to know the range of the function. Okay, so in this case, there is an equation that we're going to start off by writing. So if I find the cost, that means that $500 is the initial amount. For the phone itself, that's a constant. Nothing's going to happen there. So with that, I will add 80 times t, where t represents each month. Now, for this, there is a whole lovely formula for average cost of paying off the repairs, but in the end, this is just asking for the range of the function. So keep in mind that range represents the y, or the dependent variable. X is always the independent variable, which always correlates with time because time is independent. So in this case, I'm just looking for, well, t would be the x value or the domain, the independent variable. So that would leave c, or the cost, to be the range or the y value. So the range of the function, you can kind of analyze it from what is the least amount to the most amount that I'll pay at one time. So for the range, I could pay from $80 to a total of $580 because one day I may just pay the monthly fee, but another option is I could pay for the phone and the monthly fee all at one time. So this is what the range would be, from 80 to 580. There is a formula for the average cost of paying off the repairs, but it's not actually concerning that it's just asking for the range. So that's the shortcut. I hope this helps.